Hi guys, welcome to lesson 7.1, all about graphing two variable equations. And so we will pick this up on page 111. So the object here is we want to be able to write equations in two variables to represent relationships between quantities, stuff that they're going to give us that just sounds like real life. And we're going to want to be able to graph equations on coordinate axes with labels and scales. Sometimes that's the hardest part, choosing the proper scale, making sure we label the independent and dependent axis with the proper units and stuff. And we want to be able to describe the domain and range of a linear function. So domain and range always take a little bit of abstract thinking. Abstract, that's easy for me to say. All right, so let's start out here. Travis Smith and his brother Roy are co-owners of a trucking company. They want to increase their business, so they budgeted $1,360 for 1 month of advertising. After doing some research, they decided to advertise their trucking service to farmers using billboards on state highways and radio advertisements. Billboards rent for $100 per month, and radio advertisements cost $40 per 30-second ad. All right, let's see what we're going to do with that. All right, so as usual, I'm going to encourage you to please do this on your own. Pause me, do it on your own, and then listen and see if there's anything you want to adjust. If you just take down a dictation, then you're not, first of all, it's going to be too boring. And secondly, you're not going to be thinking deeply enough about this so that you can really do it by yourself. So the best thing to do is try to be as independent as possible from the get-go. So see if you can fill this in. Travis and Roy want to know how the rental of each billboard affects their available money. Fill in the table below and plot the points on the grid. So go ahead, do it by yourself. So hopefully you figured out they started with $1,360 for their advertising budget. And for each billboard rented, those were $100. So that would be $1,260 for one. That's how much they'd have left. And then if they bought two, they'd have $1,160 left. If they had three, $1,060, four, $960, five, $860, and this does not say six, so hopefully you were paying attention. If they bought 8 billboards, that would cost them $800, so they'd only have $560 left. And if they bought 10, that would be $1,000 and they'd have $360 left. And if they bought 13, they'd only have $60 left. So hopefully you're reading carefully. That seems like a great thing Springboard might spring on you. Ha ha, you see what I did there? On a test. So here, the cool thing about this graph is that they've already given us, they've shown us the independent variable and the dependent variable. How much money they have left depends on how many billboards they rented. And they've also chosen the scale for us. So they're going by singles on the x-axis, and they're going by hundreds here. That made sense because for every billboard it's going to cost 100. Sometimes it's not that easy, but it's nice when they put the scale together for you. So they start off with 1360, so that's going to be like around here. And then for one, they'd have 1260. For two, they'd have 1160. Oops. For three, they'd have 1060. For four, they'd have 960. 860. For 8, they'd have 560. For 10, and so on. Something like that. Hopefully that's how yours looked. So on the graph, I noticed that it's going down, and it's going in a linear pattern, which would imply that, do you remember what that would imply? That there is a constant rate of change. So if we look at the table shows a $100 decrease for each billboard. So it does sound like a constant rate of change. Explain how you determine the values for renting 8, 10, and 13 billboards. So by all means, you did it by yourself, so explain how you did it. I basically knew that each billboard, that's an O, was 100, so I just subtracted subtracted 100 for each additional billboard. So if I was doing 3 more billboards, I subtracted 300 and so on. So we're going to write an equation for the amount of money, M, that Travis and Roy have remaining in terms of, that means the independent will be in terms of the number of billboards rented, B. So in terms of billboards, so that means the money's going to depend on the billboards because it's in terms of billboards. So lots of times we use X and Y, but here they've given us the variables. So see if you can write it with the proper variables. And hopefully you came up with something like this. They started out with $13.60 and they're going to lose or spend 100 per billboard. So what is the domain of the function that just got described in item 4? Think about that. What's the domain? You waiting for me to tell you? I hope not. The domain would be 0, 1, 2, 3, 4, 5. Do you understand why that's right? Well, if you think about what the domain represents, remember the domain dominates. It's the independent variable. It controls the whole situation. So the domain represents the possible number of billboards they rented. So they can rent anywhere from 0 to 13 based on their budget. Now what's the range of the function in item 4 and what does it represent? See what you can do. Hopefully that makes sense to you. And that's because the range represents the possible amounts of money that Travis and Roy could have left. Represents amount of money Travis and Roy could have left after renting billboards, or not renting billboards if they rented 0. So if they rented 0, they'd still have their $13.60, so that's the highest. And the most they could rent would be 13 because they wouldn't have enough for a 14th one. So this is good stuff to be able to explain. Not particularly hard, but sometimes a little hard to come up with on your own. So hopefully you're trying these independently during the mixes. And bring me questions if you're getting stuck on things. So suppose we draw a line through the points on the graph in item 1. So that would look like, well, pretend this is a line if I actually had a ruler. I've done worse. What information do the values 100, negative 100, and 1360 from the function in item 4, so here's the function from item 4, What information do those two values give us about the graph? Use mathematical terminology in your answer. I'm pausing because I hope you are pausing me. Alright, so I'm going to presume you paused me and tried it, and maybe you said something like 1360 is the y-intercept of the graph. That's where the graph hits the y-axis, right there. Well, it's the m-axis, but we'd still call it the y-intercept in this coordinate plane. And negative 100 is the slope. The line goes down 100 for each one billboard. So Travis and Roy also need to consider how buying radio advertisements will affect their money. So we're going to write an equation for the money they have left in terms of radio ads. So if you remember from the beginning, the billboards were $100 a month and radio ads were $40 per 30-second ad. So their money, if they had their $13.60 to start with, would go down by 40 per radio ad. And now we're going to graph that function. So let's see. If they didn't buy any, they'd be at 1360 again. And then let's see. This is going by 4, so they must be going by 5s. So if they bought 5 radio ads, they would spend $200. So that's going to go down 200 for 5. And if they bought 10, they'd spend 400. So it would look like this, and hopefully you can see the general pattern going down 200 for every 5 radio ads, and then it's gonna have to, they'd run out of money before they even bought 35 ads. Think about that. Make sure you understand it. 40 will only go into $1,360 34 times. So that's the most radio ads they could possibly buy. What kind of function was that we just wrote? That's a linear function. You know how you can tell it's a linear function? I hope you do. Because it has a constant rate of change. Let's see, the rate of change of a function is the ratio of the amount of change in the dependent, so that's the change in y, right, the dependent, to the amount of change in the independent, that's your x. So change in y as relates to change in x. It's a ratio, rise over run. So the rate of change in the function we wrote, including the units, is negative $40 over 1 ad. What does the y-intercept of your graph represent? 1360 is the amount of money they started with, or the amount of money they would have if they bought 0 ads. Hopefully that makes sense. And these are good things to note here too. So take a minute, make sure you're studying those things deeply so you can own them. Here's a great question. Are all of the values for R on your graph valid in this situation, given that R represents the number of radio ads that they can buy? Well, it depends. If you connected the dots, they're not all valid. If we just drew dots, they are. But if you drew a line, the whole line would not be valid. Can you think of why? Because they can only buy whole ads, not any decimals or fractions, not partial ads. So it wouldn't really be continuous. It would only be on those whole number values. All right, well that gets us to where we can pick it up in class and talk a little bit more. So be sure to bring your questions and I'll see you there.